Welcome to the Shika Serbu Motor channel. This channel provides easy-to-understand explanations of car mechanisms. The topic of this video is hybrid systems. Today, many car manufacturers have developed their own hybrid systems and introduced them to the market. This video will showcase some of them. Hybrid systems utilize electric motor in addition to the engine as a power source. The electric motor and generator are controlled by an inverter and are equipped with lithium-ion or nickel-hydrogen batteries for charging and discharging. In this video, an electric motor primarily used for driving a vehicle is referred to as an electric motor, and an electric motor primarily used as a generator or engine starter is referred to as a motor generator. Currently, three types of hybrid systems are used. A series hybrid uses the engine solely for electricity generation. The electric motor is powered by the generated electricity, and the vehicle is driven solely on the electric motor power. A parallel hybrid operates the vehicle using three methods: engine only, electric motor only, and both the engine and electric motor. Typically, it starts with the electric motor, switches to the engine when the vehicle reaches a certain speed, and assists the engine with the electric motor when significant acceleration is required. A power split hybrid system divides the engine output into power generation and propulsion through a power split device. This allows for the most efficient use of the engine depending on the driving conditions. THS, the Toyota Hybrid System, is a type of power split hybrid system. An electric motor, a motor generator, an engine, and an output gear are interconnected through a planetary gear set to control the power flow. If you are not familiar with planetary gears, please watch the video, "What is planetary gear and hydraulic multi-plate clutch?" before watching this video. The link is provided in the description. First, let's take a look at the arrangement and connections of each component. The electric motor and internal gear are directly linked to the differential, meaning that the rotation of the electric motor is transmitted directly to the tires. The motor generator is connected to the sun gear. The engine is connected to the planetary carrier through the motor generator and the sun gear. When the vehicle starts, the engine is not used, and only the electric motor operates. When the vehicle reaches a certain speed, the motor generator operates as a starter motor and starts the engine. During consistent speed driving, the electric motor is stopped, and the vehicle runs solely on the engine. At this time, the motor generator is operated as a generator. The varying amount of generated electricity changes the load of the generator and resistance of the sun gear. Therefore, the varying amount of generated electricity changes the vehicle speed, while the engine speed remains constant. Now, when the electricity generation of a motor generator is low, it means that the resistance of the sun gear is also low. Therefore, the internal gear speed and output speed is low. Increasing the electricity generation of the motor generator results in a lower rotational speed of the sun gear, leading to higher speeds for the internal gear and the output rotation. When the electricity generation is increased further, the internal gear and output rotation speed will increase even more. In this way, THS can adjust the required vehicle speed and power generation continuously while maintaining the most efficient engine speed. During acceleration, the electric motor torque is added to the engine torque to generate sufficient acceleration. During deceleration and regenerative braking, the motor generator operates as a generator to charge the battery. The THS shown in this video is the first generation that appeared in 1997. Today, Toyota cars equipped with 4th to 5th generation THS are available for sale. Renault E-Tech is also a type of power split hybrid, but unlike THS, it uses a dog clutch transmission in its power split device. If you're not familiar with dog clutch transmission, please watch the video, Manual Transmission and Clutch, How They Work. The link is provided in the description. First, let's take a look at the arrangement and connections of each component. The electric motor is connected to a shaft with 2 fixed gears. The shaft connected to the engine has 2 shiftable gears and 1 fixed gear, arranged coaxially with the shaft of the electric motor. The counter shaft is equipped with 2 shiftable gears and 1 fixed gear. The output shaft features 3 fixed gears and 2 shiftable gears. It outputs power to the differential from one of the fixed gears. The motor generator is connected to the fixed gear on the counter shaft via an idler gear. At the vehicle start, the engine is not used, and only the electric motor is in operation. During this time, the lower gear on the output shaft is engaged, and power is transmitted through the following sequence: electric motor shaft, output shaft, and the differential. When the vehicle reaches a certain speed, the motor generator operates as a starter motor and starts the engine. After the engine has been started, the low-speed gear on the engine shaft engages, and the engine output is transmitted to the output shaft. As the vehicle speed increases, the transmission on the engine side changes the gears. E-TEC combines engine side 4-speed gears and electric motor side 3-speed gears, depending on the driving conditions to enable driving and generating. If large regenerative braking is required, the engine side transmission is shifted to neutral, allowing all the driving force from the tires to be directed to the electric motor. It generates a significant amount of electricity and braking force. Nissan e-POWER is a series hybrid. The electric motor and engine are not mechanically connected. The vehicle driving force is produced by the electric motor, while the engine solely powers the generator. When starting the vehicle and during low-speed driving, it operates using the electric power charged in the battery. When the battery level decreases, or during heavy load conditions, such as strong acceleration or high-speed driving, the engine operates to generate electricity while the electric motor propels the vehicle. The Honda 2-motor hybrid system combines the features of a series hybrid and a power split hybrid. There is 1 gear fixed to the engine output shaft, and additionally, it has another gear through a hydraulic multi-plate clutch. The electric motor is engaged with the gear through the hydraulic multi-plate clutch. The motor generator is engaged with the fixed gear on the engine output shaft, through the electric motor. The differential is connected to the gear of the hydraulic multi-plate clutch on the engine output shaft via an idle gear. During normal driving, it operates as a series hybrid. The engine and output shaft are not mechanically connected, and the vehicle runs solely on the electric motor. In situations requiring battery charging, such as rapid acceleration or low battery charge level, the engine activates the motor generator to generate electricity. During highway driving, the engine is more efficient than the electric motor. The system connects the engine and the output shaft using a hydraulic multi-plate clutch to enable propulsion through engine power. In the latest 2-motor hybrid systems, the electric motor and motor generator are arranged in parallel. A parallel hybrid system uses a single electric motor for driving the vehicle, generating electricity, and starting the engine. Similar to other hybrid systems, it starts with only the electric motor and adds the torque from the electric motor in addition to the engine during acceleration. It charges the battery during deceleration, but it cannot charge the battery when driving with the electric motor. In PHEVs, plug-in hybrid electric vehicles, due to their large capacity battery, demand for battery charging is lower compared to HEVs. Car manufacturers such as Mercedes-Benz, Stellantis, and Mazda have adopted a parallel hybrid system for their PHEVs. Mercedes-Benz uses a torque converter, whereas Stellantis and Mazda employ a hydraulic multi-plate clutch as an alternative to the torque converter. Thank you for watching. If you enjoyed this video, please consider subscribing to our channel. We'll see you in the next video.